This conference will now be recorded.
Hello students, today's topic is free radical substitution reaction and electrophilic substitution reaction. But before starting, if you didn't subscribe my channel, then please subscribe my channel and hit the bell icon to get the latest update of my channel. Now, what is free radical substitution reaction? Before starting, firstly we should know what is substitution reaction. As the name indicates, substitution means substitution. It means replacement. When one free radical substitute with another free radical, that one is called as free radical substitution reaction. Here, the free radical means any unpaired electron pair. Okay, any species that contains an unpaired electron in the valence shell of one of its atom, that one is called as free radical substitution reaction. And this free radical formed during the reaction carried out at high temperature in the gas phase or in non-polar solvents in the presence of a substance known to produce a radical like peroxide. Example here, A, B plus C, that will make a B plus AC, where you can see B is replaced with C. Here B is your one free radical and C is your another free radical. So one free radical is substituted with another free radical. The examples are CH3 dot, CH3 CH2 dot. The dot represents a free radical. Now these are the features of free radical. They are very reactive and salty. They are formed by homolytic cleavage. Homolytic cleavage means there will be a equal distribution of electron. Okay, we will see the example in the next slide. Next one is the formation of free radical is always initiated by helper. What is helper? Helper is a mnemonic to learn these things. The examples are heat, electricity, light, peroxide, and radical. In the presence of heat, electricity, light, and peroxide, these free radical can be generated. And the mechanism of free radical substitution reaction involves three steps. That thing you have to learn. The steps are chain initiation, propagation, and chain termination. Now come to the next thing, free radical substitution reaction mechanism. Now in this free radical, before starting free radical substitution reaction, I'm going to tell you, listen me carefully. Then only you will be able to understand this thing. These free radical substitution reaction, the famous example is halogenation of alkane. This one is the halogenation of alkane, where alkane is your methane. Methane is reacted with this one chlorine molecule in the presence of HV. That one indicates your sunlight or UV light. That one H is replaced with Cl. That one is called a substitution reaction. Now, this one is the mechanism. After listening to me, then surely you will get the very easy method of this free radical substitution reaction. But before starting, you have to imagine, suppose that you have two containers. Okay, you have two containers. In one container you have taken a chlorine molecule, in another container you have taken a methane. Now you have kept both containers into the sunlight. What will be happen? This chlorine molecule, it will be broken down in the presence of UV into a free radical. Now you should know very well, these one free radicals are more reactive because they have got the energy. So in the initiation step, I have written here ClCl. As you know, this one ClCl bond is more strong bond, so they need a energy to break down. So in the presence of UV light, there will be homolytic cleavage. One electron will shift to this side, while one electron it will shift to this side. They will make a free radical, Cl dot plus Cl dot. The next thing, in the next step, as I told you, now they have composed into a free radical. Now if you take this one free radical, now this one Cl dot free radical, now it will be more reactive, so it want to react with any other particle. So suddenly he saw that beside this there was a methane molecule container. Okay, now what will be happen? Now this one chlorine molecule, it will urge to this one methane molecule that please break down of your bond. So because please break down of your bond, because I have to react. So what can it do? This one methane molecule on the request of chlorine molecule, it will break down its bond. what will be happen again? One electron will shift to this side, one electron will shift to this side. So H dot and Cl dot, the next thing there will be CS3 dot. Now chlorine have two choices, either it will make with H dot or C or CS3 dot. As chlorine knows that it will make a strong bond with H dot, so it will make dot and dot, it will make a one bond, they will make a HCl plus CS3 dot methyl radical, it will be eliminated. Now the next thing, as you know very well, now methyl free radical, now it will say because of this chlorine molecule I have just unstabilized. Now as I was in the condition of methane molecule, so stable, so strong, and now they have broken me into a radical form. Now this one methyl radical will say that you have destroyed my life. Now I will do the same with you. Now again, this one methyl free radical, it will react with chlorine. This one ClCl, right? Now it will react with ClCl. Now I will destroy your life. Now it will say again to chlorine that now chlorine, sir, now you have to break down your particular bond. Now what can it do? Now again chlorine molecule will break down its bond. Now one electron will shift to this side, one electron will shift to this side. Now CH3 dot plus Cl dot, it will make a bond CH3 Cl. Next one Cl dot, it will be eliminated as a free radical. So as in the propagation step, always already formed free radical will make a more free radical, and that one is a propagation step. Okay, now come to the termination step. In the termination step, what will be now here? For the termination, you have to see what are the free radicals are there. Cl dot, CS3 dot, there are two free radicals you have generated. In the termination step, all the radical, whatever you have prepared, just write down Cl dot, Cl dot, CS3 dot, Cl dot, CS3 dot, CS3 dot. They can be possible, these can be possibility. So you can write here dot dot, it will make a bond. So ClCl, CS3 Cl, CS3 CS3 CS3. So don't think there will be only one product, there will be three product formation. Okay, so now hopefully you it will be an easy method for you to learn this thing. Now come to the next slide. Next slide is our electrophilic substitution reaction. Next slide is our electrophilic substitution reaction. Now electrophilic substitution means when the electrophile attack on the benzene. Already I had told you what is electrophile. Electrophile means those species which having a positive charge. Next thing, they will always attack to a negative charge species, that means nucleophile. Now this one electrophile attack on the benzene ring, it will replace one of its hydrogen, as we know very well. Substitution means replacement. Okay, so here as you know very well, in the benzene ring, each carbon atom having a 1 hydrogen atom is there. Okay, each carbon atom having a 1 hydrogen. So now from here, one hydrogen, it will be replaced, as you can see here this side, and one electrophile, it will shift to this side. So this one, it will make a electrophilic substitution reaction. So now in the electrophilic substitution reaction, this one there are three steps. All the steps name, if you have learned it, then surely you can proceed the reaction. The mechanism is, first thing you should know very well, there is a one benzene ring, it will react with bromine molecule in the presence of catalyst FeBr3. Now this one FeBr3, it will act as a Lewis acid. Okay, and it will make a electrophilic substitution reaction plus HBr. Now just see the mechanism. The first step is formation of electrophile. Here we have taken this one bromine molecule. As we know, bromine bond, this one single bond, this one is more strong, so it will not directly react. It will react only in the presence of catalyst, that one is FeBr3. This one FeBr3, this one is a Lewis acid, so it need an electron. So now this one bromine, it will shift to this side, it will make a FeBr4 minus and plus Br plus. This one is a one electrophile, it will be generated. Now the second step, that one is electrophile attack on the benzene ring. In this electrophile attack, there is a one benzene ring is there, it will react with this one electrophile. What will be happen? There will be a formation of arenium ion. This one is called as arenium ion. Why? because when the bromine will attack to this, as you know, this one is a benzene, it having a pi electron cloud. So here electron will be shift in the direction of, here electron will be shift to this side. What will be happen, from where the electron will shift, that carbon atom will get a plus charge, as you can see here, and to that atom where the electrons are shift, that will get a bromine and H. There was a H and one bromine, it will be attached to that carbon atom. Okay, so now this one is a not, now this benzene ring or this arenium ion have lost their aromaticity. Now it is unstable. We can see this one is rate limiting step. Now to make it stabilize, it will undergo a resonance. Now resonance means, as I had told you, resonance means when the older bond will be broken down and new bond will be formed. As here you can see HBr, it will be remain same in these three intermediates. Now here what will be happen, now this bond electron, it will be shift to this side. What will be happen here, new bond will be formed like this, and this carbon atom will get a plus charge. Okay, now the older bond is this one was new bond, so you have not to touch it. Now this pi electron, it will shift to this side again, this one will get a new bond formation, and this carbon atom, it will get a plus charge. Okay, so these things we can also say that these particular things are a carbocation formation. These intermediates are carbocation intermediate. Now come to the elimination. As the thing which we have got in the step 2, that particular compound will react in the presence of FeBr4 minus. Now what will be happen here, one H plus or one hydrogen, it will be taken up by Br. What will be happen, HBr, it will be eliminated, one Br, it will be remain same, and FeBr3 will be, here this should be Br3, so one FeBr3, it will be eliminated, and now from here new bond will be generated. So you will get your particular electrophilic substitution compound. Okay, so hopefully you have liked these videos. Hopefully you have liked this video. So if you like it, please subscribe and press the bell icon. Thank you.